You like my glasses?
Woo! Very intelligent.
Oh, I'm intelligent.
Wait, is this on the packet yet?
Yes.
Yeah,
All right.
I don't have my packet.
Number 9. So number 9 on the packet. Here's one if you want.
No, I already got one.
Okay. All right. Number 9 on the packet is this triangle. Right? It's actually 2 triangles. And the way we're going to look at this, Hazen, is this middle triangle compared to the big triangle, right? Compared to this guy. And the one thing, if they are similar, then either we can prove that all the sides are similar, meaning they're proportionate, right? Or if we can prove that the angle, all angles are proportionate, or if we can prove that the 2 sides and the angle in between the 2 sides that are proportionate are all proportionate, okay? So, now the angles will be the same. The sides will be what we call proportionate, meaning a certain ratio we can use to multiply one side to get to the other side. And that side, that ratio should work with all of them. Okay? Alright. As in alpha or beta. These are similar triangles, right? So that's how we're trying to figure that out. Alright? So, let's think. 8, right? How can we go from 8 to 52? How do we go from 8 to 52? Right? Well, no, remember, a ratio is multiplying, right? Ratio is multiplying. So, we want to multiply something by 8 to get to 52. So, in essence, 8x would equal 52. Right? So then, how many times does 8 go into 52? 8 goes into 48 6 times, and it's 4 away, right? So that's 4 left over. 4 over 8 is a half, right? So x is actually equal to 4 or 6 and a half. All right? Now that's our ratio. That's our ratio. So that means that if I multiply, well, how do I turn this into a mixed fraction? Well, that is a mixed fraction. How do I turn this into an improper fraction? Yeah, 6 times 2, just 12, right?
Yep.
Times, or add to 1, right? So 13 over 2. So in other words, that's 7. So 13 over 2, right, times 8 should give 52. Is it true? Well, 2 goes into 8 4 times, right? What's 4 times 13? 4 times 10 is 40. 4 times 3 is 12. 40 and 12 is 52. So it works. Okay? It works for that side. So for that side to become that side, right? Alright, so then, which side do you think? Do you think this side is proportionate to this side? Or do you think this side is proportionate to this side? And so that's the question you're going to ask yourself. And so we did the times the smaller number, right? Okay? So, I'd have to know this side. I don't even know this side. How can I figure out that side? Okay? So the first things we did was we said, we're going to figure out the ratio. So definition of a ratio, right, tells us that we have 8x equals 52. And then we said that we divided on both sides, right? And that's division property of equality, right? And then we said x was equal to either 6.5 or 13 over 2, right? And that was the definition of a ratio, okay? Now, I can erase that part and get moving on some more. All right, so how am I going to find the sides? Remember, two sides add up to be the bigger side, right? So I should know that 88 plus SV, right, should equal 104. Does that make sense? Right? Because the big piece is 104. This piece is 88. So this little piece, SV, right, should be the difference. So how do I know this? Segment, addition, postulate, right? Okay? So then I subtract 88. Subtract 88. SV should equal, well, it's 20 plus 2 plus 4. 26? Right? Is it, no, 10. My bad. 10 plus 2 plus 4. Okay? Because 90, 88 is close to 90, right? Plus 2. Plus, so 10 plus 2 plus 4 is 16, right? Got me? 18. Alright, so, what is that? Subtraction property of equality, right? Alright, so we know that SB is 16. What's this side? How do we know that side? So that's 16. How do we know the other side? So wouldn't it be the same thing? Set up 99, right? Plus SW should equal 117, right? And that's again segment, addition, postulate, right? And so then I subtract subtract 99, and I get SW, subtraction property of equality. I get SW is equal to what? 18? Y'all follow? Right, Riley? Got that? So this is 18 right here. So is this bigger than that side? So it's really small, medium, large, right? Small, medium, large. Then we want to look at the big triangle. Small, medium, and large. So that's the way that that should work. So if that works that way, what triangle would this be? If it's S, R, Q, then the little triangle is going to be S, V, W, right? Now, we don't know if that's true yet. Okay? But that's what we think, because it goes SV, right, is your medium, and then your small, and then your large. And SR is your medium, and then your small, and then your large. Does that make sense? On that whole SRQ thing? So SR is your medium, right? And then RQ is your small, and Q to S is your large, right? Am I making sense? Or am I just talking gibberish? We good? Okay. Alright, so that's what we're trying to prove. And how we're going to try to prove it is with this ratio. Okay? So, with that ratio, then like I did before, when I multiplied 13 halves, right, times 8, the smaller triangle, I got the bigger triangle side. Does that make sense? So if I can multiply this smaller side, right, 16. So if I can do that, if I go 16 times the ratio, right, the ratio of 13 over 2, right, that needs to equal what? 104, doesn't it? If it does, we're almost there. It means we have two sides that work, right? But that's just SS, right? And SS is great as long as I can prove that this angle works, then boom, but I don't know that angle. So I'm going to have to go for the other side. You see where I'm going with this? Okay, so SS first. So this is going to be 104, I hope. I hope. So then let's prove it. Okay? So this is the definition, right, of similar triangles, of similar sides. Means that their ratios should all be the same, right? So, what is 2 going to 16? What's half of 16?
8.
8.
Wouldn't it be 88?
Right. So that would be 8.
Wouldn't it be 88?
Why would it be 88?
Um,
Because of this?
yeah.
But that's only part of that side. We want the whole side. That's why we're trying to get to 104. Does that make sense? Okay, and then so what's 13 times 8? What's 8 times 10? 80. And 3 times 8? 24. And they add to be 104. So it works, right? So we know the second side it works. So we know right now, due to SS, right? And we don't know the A, so we can't put the A in here. Otherwise, we could go SAS. Boom, done. Right? If we could prove that this angle in between those sides, we could prove SAS and we'd be done. But we can't prove that. Right? So we got to go to that last side. So let's go to the last side. So the last side, you help me out. I'm going to take this 18. And what am I going to multiply 18 by? Sorry. What do I multiply 18 by? What's the ratio? 13 over 2. Thank you. Is it always going to be 13 over 2 for all the problems? No, it's just this problem, right? Every problem has a different ratio, right? Okay? And then what is that going to equal? What side is supposed to be similar to the 18? 117. Good job. Right? So it should be equal to this last side. Does that make sense? Okay? So, what is half of 18? 9. Okay? And then what's 9 times 10?
90.
90. And what's 9 times 3? 27. 9 times 3? 27, right? And then add 90 and 27. 117, right? Boom, shakalaka. And we got our third side. And so due to SSS, right? Because each side is proportional to the other side, we can prove that these two triangles are similar. Yay team. Questions? I know there's some questions. I'm not that good of a teacher. Come on now. I know I'm good. You know, we all know that. Okay. Yeah. But am I that good? Come on, we got questions. No questions? Go on, Hazen. Hit me hard. Come on. Jeremiah, no questions? That's amazing since you didn't pay attention to most of that. Lily, question? Do you understand it? No. Okay.
You done?
Question? What's the question? Is it all of it?
Yeah,
Some of it?
all of it.
Want me to walk through you again? Alright. First step. Right? First step was to figure out a ratio. If I can figure out a ratio for one of the sides, right? Then I can figure out a ratio for all the sides. I guessed at this. I guessed that this was the shortest side because it looked like the shortest side. Just because it looks like it doesn't mean it is, right? So that was a guess. I went for it. You know, hey, I was right. Okay? So I said x times 8 should get me 52. Some kind of number times 8 is going to get me 52 if they're similar, right? So I found that number to be 13 over 2. And then that same number times 16 should get me 104. And it did. And that same number times 18 should give me 117. Now why did I link those up? Now remember, this is the shortest side, right? 8. And this is the shortest side, 52. Right? And this is the medium side, 8, 16, 18, right? And 104 is the medium side for the other. See what I'm saying? And then the large side was 18, and that matched the 117. Does that make sense? Now it won't always be that way. Sometimes they're flipped. Okay? But for this one, it worked out that way, and it's all good. Okay? So does that make sense? Some number times 8 is 52. That same number times 16 should be 104. And that same number times 18 should be 117. And we found that number to be 13 over 2. Okay? In proportionality, it's always some number. We don't know what number. We have to figure that math out, right? But after we have that number, we should be able to do it. Now, like I said before, if I was working with SAS, right, then I could have done this same problem if I knew that this angle was, say, 38, and this angle was 38. You see what I'm saying? And I found that this was 16, and this was 104, and this was 8, and this was 52. You see what I'm saying? So the same number times 8 is 52. The same number times 16 is 104. So I know that this side is proportionate to that side. I know that this side is proportionate to that side. And these angles are the same. So in that case, it would be SAS. See how that works? Not this angle, because that's not SAS, unless I do this side. Does that make sense? So, or actually that wouldn't work either, because that would be side-side angle. And angle side-side does not work in similar triangles. Okay? So only SSS, SAS, or AAA. So all the angles are congruent. Boom. Does that make sense? Better? Probably not perfect, but we're better. We're better, see? A little bit better, tiny bit better, a whole lot better. Who knows? But I love you nevertheless, right? Let's go.